So we're going to be looking at question 2 on paper 2 here. This question, as it says, is about an IV graph produced on a resistor. And we've got the data fully provided here without having to plot any additional points. I've got to say, whilst a handful of you are good at plotting a line of best fit, there are far too many who need to practice it a lot more. So that's something I think we need to do more when we come back. This one here is excellent. You can see it's one continuous line. It's straight along these sections of the graph where the behavior is still ohmic. So I guess what I'm saying there is that current is proportional to voltage for this section of the graph. But then after we get past this kind of 8th point, really, it starts to curve downwards. So this is pretty ideal for me. You can see here that it's kind of all been drawn by hand, or if there was a ruler involved here, then it's been done so smoothly that you can't really tell. Another excellent feature of this graph is that all of the line is within the width of the crosses. The width of the crosses here tell us the uncertainty in these measurements, the absolute uncertainty. And this line just about is pretty close there. But you can see it's clearly trying to keep it within the space that those crosses are in. So this is a really, really good one and definitely earned a mark. So that's the first mark that's available. The second mark is available for saying, well, at which point, what is the greatest point at which R obeys Ohm's law? And obeying Ohm's law means the proportionality that I just mentioned, where I is proportional to V. So it's the straight line part. Now, it's a straight line up to about here. Interestingly, in the mark scheme, they would allow this, but can you see that not so much this point, but this 10th point here also kind of does carry on that straight line. So you could have chosen either point 8 or point 10, but not point 9, which is a shame actually, because we did have one student who did that, and I can totally understand why you would. So yeah, one of those two there. After that, it's pretty clearly curving off. So that's the first 2 marks. Question 12.3 says determine the percentage increase in the resistance of R from its value of 22.2 ohms when it's basically obeying Ohm's law to whatever it is a bit higher up at 55 times 10 to the minus 3 amps. Now, when we reach this current, it has started to curve. Now, frankly, whatever line you drew, as long as you did this correct for your line, well, we should be in business. So what you need to do is go over to your graph and take a reading of V and a reading of I and divide one by the other to get your value of R, which this student has done. Then you find the difference in the value of R and divide it by the original value, which here is 22.2 ohms, and we'll times it by 100 to form a percentage. Now, as long as you've done the steps of correctly obtaining a resistance value and you have also turned that into a percentage difference, then you'll get both marks that are available here. The sort of mistakes that I did sometimes see where some people just didn't really know how to calculate percentage difference. If that's you, make sure you're confident in that. And I saw maybe 1 or 2 people who just read off the graph a little bit poorly and didn't get the mark. Now, the last question in question 2 is 2.4, and we're given an arrangement of 4 different circuits, and we're basically asked to deduce which one was used to obtain the results that we saw on the previous page. It's not a particularly easy question, and it's especially unusual because it says, well, 1 mark basically for selecting the correct one and 3 marks for saying what's wrong with all the other ones. So yeah, a process of deduction is what's required here. Now, this student's answer here, he hasn't selected the correct circuit. He selected what I would have said was my second choice, because actually circuit B would produce a decent set of results. It just wouldn't produce the range that we see. So the correct answer was D. And then we had to go about saying why. So this student hasn't got that mark, but has obtained a mark for explaining why it couldn't be circuit C. So I'll share that explanation with you in a moment if you haven't got to read it, but it's better to have a look at what we're doing by glancing over these graphs. So circuit A, the problem with circuit A is the position of the ammeter. The ammeter is reading the current through resistor P. not the current through resistor R. So it needs to be somewhere in this leg of the parallel circuit that R is on. Okay, now I'll come back to B actually, because B is a decent circuit, like I said. C is a bit more obvious. There's something seriously wrong with C. The voltage here is not across R. One side of the voltmeter is connected to one side of P, and the other to, well, wherever the potential divider is on P. So we're going to get a voltage reading out of part of P rather than across R. Now, some people thought that might be the problem on circuit A as well, but it's actually not. One side of the voltmeter is connected to one side of R, and the other side of the voltmeter connects up to the other side of R. So this voltmeter is placed perfectly well. Right, so let's come over to circuit B and see if we can figure out what's actually wrong with it. In both cases, B and D, we've got both our resistors. This is then in series with resistor P, whereas this one is a parallel arrangement. Now, the parallel arrangement is better because if I set it up this way, I can get the full available voltage across R, but I can also get it all the way down to 0 by moving this to one side of resistor P. So this will produce a range going from 0 all the way up to 15.6. Whereas because this is in series with this one, even if I make this, let's say I make this the maximum possible value so that it has twice the resistance of R, when that's the case, the sort of lowest value of voltage that I can get here, we're dividing it up in into three parts. The lowest value I'm going to get is going to be a third of that, so around about about 5 volts across R. Now, our data does go down further than that, so B hasn't been used to produce that. Okay, because yeah, like I say, you need to split that voltage up between the two resistors, and you won't be able to arrange that with a lower voltage than 14.6 divided by 3, basically. Okay, so the reason why circuit B is not allowed is basically the easiest way to describe it, and you can get the marks for saying this, is simply that it doesn't produce the range of voltages that we see in the data.